Stealth was never meant to make an aircraft invisible. It was designed to make it survivable inside a hostile, networked battlespace. In the 21st century, that battlespace has become denser and more lethal than ever imagined. Today, the promise of stealth only holds true when it works with the network, not against it. Modern air combat is defined by networks. It is a complex web of sensors, high-bandwidth data links, and distributed decision-making that connects every asset on the battlefield. In this environment, a lone stealth aircraft, no matter how advanced, is an isolated and vulnerable target. Its low observable characteristics no longer guarantee survival on their own. This video explains how stealth fits into a fully networked battlespace and why its fundamental role has been redefined from a tool of invisibility to an enabler of information dominance. Historically, stealth platforms were seen as ghosts in the machine, lone hunters designed to slip past enemy defenses undetected. But this perception misses their true value in modern warfare. Today, a stealth aircraft is a forward node, a critical sensor and communications hub operating deep inside the enemy's sensor zones. By penetrating contested airspace where conventional assets cannot survive, these platforms provide something far more valuable than a single missile strike. They deliver persistent high-quality targeting data, early warning of threats, and a secure access point for the rest of the network. The operational takeaway is clear. Stealth opens the door for the entire network to see and act within enemy territory. The very nature of low observability also provides a hidden advantage. It reduces the burden on the friendly network. A stealth aircraft, by design, needs to emit less energy to survive. This means fewer active radar sweeps and less frequent communication, which minimizes its electronic signature and limits opportunities for detection. Every moment a stealth aircraft can operate passively is a moment it is not adding noise to the network or revealing its position. This discipline simplifies the battle space for all connected forces, allowing them to focus resources where they are needed most. In this way, stealth buys the entire force precious time and preserves valuable network bandwidth for critical operations. The modern stealth aircraft is less a fighter jet and more a flying information processor. Its survival depends on its ability to build a complete picture of the battle space through sensor fusion. Onboard systems seamlessly combine data from its own low-probability EV-intercept radar, passive infrared sensors, and electronic intelligence receivers. But crucially, it also integrates off-board data streamed from satellites, drones, and other friendly aircraft. This fused data creates a single, coherent tactical display that allows the pilot to understand the environment not just in fragments, but as a whole. The platform ceases to be just a weapons carrier, becomes an intelligent node that processes information to make superior tactical decisions. In this networked reality, the idea of a single, decisive stealth platform is obsolete. An individual aircraft, no matter how low its signature, has inherent blind spots and vulnerabilities. However, when these aircraft operate as a distributed, networked formation, their effectiveness multiplies. They share sensor data to cover each other's blind spots, cooperatively build targeting tracks, and distribute mission tasks to enhance mutual survivability. If one aircraft is detected or threatened, another can use that information to engage the threat or maneuver to a safer position. Stealth's true power is not additive. It is exponential. Its effectiveness scales directly with the quality and resilience of its connectivity. Consequently, the fight to defeat stealth has also shifted from a simple contest of radar power to a battle between competing networks. Modern counter-stealth strategies do not rely on a single powerful radar to burn through a low observable signature. Instead, they employ distributed systems like multistatic radars, which use geographically separated transmitters and receivers to detect faint reflections from multiple angles. This data is then fused and processed by a sophisticated command and control network to build a track on a stealth target. The real conflict is no longer stealth versus radar. It is the stealth-enabled network versus the detection network. Ultimate survival depends entirely on achieving network dominance. In summary, stealth is not obsolete, but its independence is. The attributes that once made it a revolutionary standalone capability, observability, and surprise, are now components of a much larger system. In modern air warfare, stealth survives, and more importantly, it succeeds, only as an integral part of a connected, resilient, and intelligent network. It It is no longer about the platform. It is about the system the platform enables. If this breakdown clarified modern stealth warfare, like the video and subscribe to Cut Everything. In our next episode, we will analyze why future fighters are being designed as team players, not lone hunters. Comment below with your analysis. Is stealth still a decisive advantage without clear network superiority?